Hello, algebra students. Okay, so with Ms. Humphrey's project, I'm thinking that some of us might be curious how we can create our own problems for these algebra, for the calendar, or the clock, or whatever not. So I'm just going to pose my ideas at how I would approach it. Now, there are other ways to approach this, and you might think of it differently, and that's fine. But I'm going to show you how my mind is going to work. So for these first four I'm going to do, I'm going to reverse engineer one-step equations. Okay, so normally when we're reversing an equation, right, we want the end result to be something. Now, you're going to have these days of the month. I'm going to pick a particular day because it's my birthday. My birthday falls on the 15th of June. So my x, and for all my examples, I'm going to be working to get to 15. So now the question really is, how do you make a one-step equation? Well, what I want to have, let's say one way, is x plus something equals something else, right? That's a one-step addition, or I could do x minus something equals something else. But in the end result, I want to get x equals 15. So my two ideas for addition here, well, if I'm doing an addition problem, my what you call it, my inverse operations would be negative, right? So I look at this, I go, well, what number can I subtract to get 15 here? So, well, I want this to subtract to 15, okay? And this should go to 0. This one should go to 0, this one. So I'm going to say, all right, let's pick a number. I'm going to pick the number 20. 20 minus what gives me 15? Well, 5. 20 minus 5 gives me 15. So that means over here, I want something that if I subtract from 5, it's going to equal 0. Well, that's pretty simple. 5 minus 5 is equal to 0. Pretty straightforward. This is just how I'm doing it. As I said, you might have another way. So here we're going to go again. This time I'm going to try and use some subtraction, which means my inverse operation is going to be addition. Now, I'm going to pick a number. Don't want to pick a negative. No, let's pick a number like 7. 7 plus what equals 15? Well, 7 plus 8 equals 15. This number could be rather random. If you're using subtraction, I would pick a number that is less than 15. If you're using addition, I would use a number that's greater than 15. So 7 plus 8. So that means this has to be 8, because when I add 8, I want it to be 0. Negative 8 plus 8 is 0. Okay, there's an idea for addition and subtraction problems. Now, let's do multiplication division. Okay, now, same idea. At the very end, I want my answer to be 15. And what I know is that here, I'm going to want to have x equals some number, x equals some number. Now, in both of these problems, there's going to be a number that I'm dealing with here, that either this multiplied by x equals a number, or this divided by, let's say, x equals a number, or x divided by a number, equals a number. So let's go the other way around. So if I'm going to do multiplication, the inverse operation of that is division. So what number divided by something gives me 15? Well, I could say if I took the number 30 and I divided it by 2, 30 divided by 2 is 15. 45 divided by 3. 60 divided by 4. Look at all the possible multiples of 15. Okay? So I would also have to divide by 2 over here. And what that would do would be, you have to do it to get rid of another 2. So my original equation would be 2x equals 30, a one-step multiplication problem. Now, let's look at this one. A little bit trickier, division. Now, what I want to do here, the opposite of division is multiplication. So I want to multiply the beginning and the end by a number. Well, since it's something that's involving division, I'm going to think, well, what number is divided? Give me 15. What number divided by 15? Well, the 15 is 5 times 3. So I'm going to put a 3 here and a 3 here. So if I put a 3 there and a 3 there, x divided by 3, we get rid of these 3, equals, as we just said, 5 times 3 equals 15. So here's one using one step with division in it. Also a fraction. So look at those. Reverse engineering, one-step algebra equations. Next one, we'll take the step forward. We'll do 2 steps.